All right, last video for 8.2.1. We're going to talk about question number 8-67 from your textbook, and there are 3 parts to this. Okay, so we're always going back to graphing, and let's just think about what these graphs are telling us about the solutions. So you guys have known this for a long time. When you see this equation, you know that the vertex is -3, -4. You know it opens upward. You know it's a parabola. This graph crosses the x-axis twice at -1 and -5. Okay, so we already know just by looking at this graph that the 2 x-intercepts represent the solutions or the roots to this equation. Okay, so we can see it on the graph. That means they're real roots. Okay, this equation has 2 real roots. Question 67, part B. Okay, this we know is a bounce at -3. Okay, we know technically speaking there is one unique solution, one unique root, but we know we call it a double root because it bounces, it happens twice. Okay, and so we know again this has one real solution. Really it counts for 2 because it's a double root, but it has one real solution. You can see it hits the x-axis just once, but it bounces. That counts as a double root. Okay, so exponent, double root. Part C is showing, well, what happens if the vertex is at -3, 5? It's still opening up. It's still a parabola. It's never going to hit the x-axis. Okay, so we know that there are no real roots, no real solutions. But we now know if we solve this algebraically, we would in fact have 2 roots. Okay, but they would be complex roots. So when you can't see where the graph crosses the x-axis, okay, there still could potentially be complex roots. And we're going to talk a lot more about that, so don't panic yet if you don't know what we're talking about. Okay, if the graph does not touch the x-axis, it just represents 2 complex roots. Okay, so bringing it back to when we did these on the board, and these were kind of fun, these made, different, weird, silly graphs. You guys already know. If both end behaviors are the same, we know it's even, an even degree. We know on the right side, if it ends going up, it's a positive polynomial function. I could throw some numbers in here. Maybe this is -3, maybe this is -1, +1, and 5. So we know for sure, if we're going to start to write an equation, we know we could do x plus 3, x plus 1, x minus 1, and x minus 5. But most of you guys are looking at this and saying, well, wait a minute, there's some really weird stuff happening in here. This is where we're going to talk about terms. Okay, so count with me. You go down is 1, up is 2, down is 3, up is 4, down is 5, up is 6. Okay, that means somewhere in here I need to have 6 roots. Somewhere in here I have to have some imaginary roots. So I can see 4. Okay, I can see 4. When I can see them, they're real. If I can't see them, they're imaginary, like my friend. Okay, this is just an indication that there are some imaginary or complex roots. And complex roots always come in pairs. Imaginary numbers always come in pairs. We're going to talk about that a lot more later, but keep that in mind. If it's coming in pairs and you already have 4, it matches up with what we already know, that this is an even degree. Okay. The last thing that we should talk about is that the degree of a polynomial always tells how many total roots there are. Okay, so this will somehow magically become a degree of 6. And again, we're going to talk way more about that later. You don't know how to do that yet. It's okay. We're going to get there. Finally, here is your assignment for today. I'm going to work really hard on shortening these up. I'm going to work on listening to your feedback. Tell me what your other teachers are doing that you like, that's working. If you're hearing about other math teachers from other either other classrooms in the building or out of the building, some other school district, please let me know what they're doing that your friends are liking or you think will work. Okay?